Alright, we're going to do a quick run through on naming acids. So the first step is just recognizing an acid. And an acid you can recognize in this unit as beginning with H. So if you see a molecule, a formula, and it begins with H, so there's a hydrogen at the beginning, consider that an acid. Now, truth be told, that's not always the case. There's things that begin with H, like water, H2O, and there's things that are acids that don't begin with H. But for the scope of this course, general chemistry, we're going to say anything that begins with H that's not water is an acid. So you see that H, you've identified it as an acid. Now you can follow the acid naming rules. So there's two different types of acids. There's oxy acids and binary acids. And to recognize those, you just look for oxygen. So the first thing you need to ask yourself is, does the molecule have oxygen in it? And if it does, it is considered an oxy acid. So that's important because oxy acids have different naming rules than the other type. So if there is no oxygen, it is considered a binary acid. And binary acids just have hydrogen and one other element. So oxy acids have oxygen, binary acids have just hydrogen and one other element, but no oxygens. And they have two different naming rules. So once you've identified it as an acid, you've identified it as either an oxy acid or a binary acid. We move on to the next step. So let's start off with the oxy acids because they're a little bit more complicated. So the first thing you want to do for oxy acids is you want to identify the polyatomic ion. And that is the one from your common ion sheet. So you look on your common ion sheet and it'll be something like hydrogen attached to, let's say, for example, H2SO4. So there's your hydrogen at the beginning. That's how you recognize it as an acid. Here is your oxygen right there. That's how you recognize it as an oxy acid. Now the polyatomic ion is going to be this little piece right here, SO4. SO4 is sulfate. And so that's going to be the next step. Identify what your polyatomic ion is and its name. And there's two different routes you can take here. So if your polyatomic ion ends in ATE, so if it ends in ATE, you change the ATE to IC. Okay, so ATE is dropped and turned to IC. And then you add the word acid to the end. So drop the ate, add the ic, acid. So sulfuric acid from sulfate. On the other hand, if your polyatomic ion ends in ITE, so if it ends in ite, you change the ite to OUS, os, and acid. So sulfite would become sulfus acid. Sulfate would become sulfuric acid. So you drop the ends and then add the acid. And those are the only two endings that come on polyatomic ions, ate and ite. And so it's just ic and os. Those are your only two choices. So identify it as an acid, identify it as an oxy acid, name the polyatomic ion, drop ate if there's an ate, turn it to ic, drop ite if there's an ite, and turn it to os. Next, let's look at the binary acids. So binary acid, there's just one type. You don't have to break it apart any further. And it's pretty simple. All you're going to do is step 1, drop ide from the anion. So it's going to be hydrogen attached to an anion. You just drop ide, so chloride, fluoride, sulfide. Drop the ide and add ic. So chloride would become chloric. And then the next thing you do, step number 2, is add hydro to the beginning. And then, obviously, acid. So hydro, anion, acid. So the basic formula for binary acid is hydro, fill in the blank with an anion, ic, acid. So hydrochloric acid, hydrosulfic acid. The main difference between binary and oxy acids, if you're doing this backwards, if you're trying to come up with the formula based on the name, then you recognize each one as binary acids have no, or oxy acids have no hydro at the beginning. So you never put a hydro on an oxy acid. Alright, hey, let's write this in our brains. Say it together. You never put a hydro on an oxy acid. You're going to get real tempted to throw hydro on things because it kind of goes along with binary acids, but do not put them on oxy acids. Only oxy acids get the hydro on them. Got it? Okay, let's practice. Alright, so you're chilling eating a blueberry muffin and you come across this HNO3 and you want to name it. So first thing you would do is you would say, hey, look, right there at the beginning, there's an H. That must be an acid. So then our next question is it a binary acid or an oxy acid? Well, here's this big circular thing at the end. That's an oxygen, which means this is an oxy acid. So we've identified it as an acid. We've identified it as an oxy acid. Next step in the oxy acid naming is identify the polyatomic ion. So that would be NO3. NO3, if you look on your common ion sheet, is nitrate. Alright, and nitrate ends in ATE, and we turn 8 to ic, which means this goes away, and it turns into nitric. Now we don't just call this molecule nitric. We have to put that acid word at the end, so we recognize it as nitric acid. So oxy acid, identify the polyatomic ion as nitrate, drop the 8, turn it to ic, and so it's nitric acid. On the other hand, let's say we get this guy. That's HNO2. So it's an acid, H at the beginning, it's an oxy acid because it has the oxygen. NO2, though, is nitrite. So what do we do with ITEs? Well, we drop them. But instead of replacing it with an ic, we replace it with an ose. So this would be nitrous acid. Okay, let's come across another acid here. So how about H2S? Alright, so we recognize that as an acid because it's got an H at the beginning. Next question, is it an oxy or binary? That would be a binary because there's nary an oxygen in that molecule. In fact, there's only two things. That's where the bi in binary comes from. There's just hydrogen and sulfur. So this would be a binary acid. So those are easy. The anion is sulfide. And we drop that IDE and turn it to an ic. So this would become sulfic. But then since it's a binary acid, we put a hydro at the beginning and an acid at the end. So this would be hydrosulfic acid. The difference between this one and an oxy acid is that hydro at the beginning. We never put a hydro on an oxy acid, but we always put them on binary acids. Alright, that's it. That's naming acids. Naming bases is simple. It's what we've always been doing. They just have a hydroxide at the end as their anion. We'll get plenty of practice with this, and hopefully you get the hang of it pretty quick.